In this section, we're going to be looking at non-right triangles. Everything we've done to this point, we've been doing right triangles, and we've been able to use Pythagorean theorem, etc. But not all triangles are going to be right triangles. So now we need some new methods and techniques to deal with a non-right triangle. And so we're going to use something called the law of sines and the law of cosines to help us deal with this. When we're looking at the law of sines, given a triangle with angles and sides opposite, labeled as showed, you can see that beta is across from B, alpha is across from A, and lambda is across from C. The ratio of sine of angle to length of the opposite side will always be equal, or symbolically, you can see that the angle and the side, when we take sine of the angle, we can put it over that side opposite to it. We're saying opposite. Look, this one is directly over here, etc. This ratio, if you are given, say, this side here, and then you're given just this angle, you can find its corresponding side just by setting up a ratio such as just these first two ratios. Then solving a ratio is no big deal. You just cross multiply and solve from there just like you would do proportions. So this law of sines can be really handy if we're giving some corresponding information and we're trying to find something that is missing. So it says for clarity, we will call A the corresponding side of angle alpha. Similarly, we will call angle alpha the corresponding angle of side A. Likewise for side B, an angle beta, and for side C, an angle lambda. And so you are going to see quite a few examples of this law of sines as we go forward, and I think you're really going to like this one. So let me give you some tips on when to use the law of sines. One, if you have two angles and any side, that would be the situation that you want to go to law of sines. Or two, if you have two sides and an angle opposite one of those sides. Those are your situations that you want to go to the law of sines. Now again, let me remind you, these are non-right triangles. If you were given two sides, do not jump to Pythagorean theorem if you do not know it's a right triangle, because it will not work. You will be working with incorrect information. Example 1. In the triangle shown here, solve for the unknown sides and angles. And this is what you're going to see in your homework and your exam. Basically, find all the pieces all the pieces that are missing. Now let me make a comment here because this kind of caught you in chapter 5 and 6. These angles are in degrees. So make sure you are in degrees. If you're using the on-screen calculator, you will have to switch it over to degrees because its default is radians, and there's a little toggle for that. If you're using a handheld calculator, you will have to find that button. And if you need assistance, please reach out. I'll be happy to help you with your given situation, whatever the calculator may be, and help you to switch that over because you're going to get incorrect calculations. And if I'm finding all the missing pieces, that means all the pieces are going to be wrong because my calculator is in the wrong one. So let's look at this problem. What I want to do is first find the things I can find most easily. And I do know that a triangle, and this goes back to previous courses, that a triangle has 180 degrees. And so just right here, I can go ahead and figure out that this lambda, this angle up here, if this is 50 and 30, that gives me 80. So this is 100 degrees just because the triangle's total angles, interior angles, equal 180. And so that's pretty quick that I can find that lambda to be 100 degrees. Now from here, I need to figure out these sides. And since I have this ratio here of 10 on one of the sides, I want to use its corresponding angle, and that relationship is going to be the ratio that I'm going to use to find the other two sides, because that is the angle and side that I currently have. So step 1, I am going to do sine of 50 degrees over 10 equal to, and so let's go ahead and find side B first. And so I'm going to say sine of 30 degrees over B, because you can see that is that relationship of the angle and side that is opposite of it. So now I'm going to solve this out just by cross multiplying and then dividing. And so when I multiply in this direction, I get 10 sine of 30 degrees equal to, I'm going to multiply now in this direction, just solving a proportion here, and that gives me B sine of 50 degrees, and then to get B by itself, I'm going to divide both sides by sine of 50. So B is going to be equal to this value. So I'm going to go to my calculator, and first I'm going to type in 10 sine of 30. I'm going to hit enter. Then I'm going to hit answer, divided by sine of 50. If you're using the on-screen calculator, this does go very nicely because you can type that all in together. You can clearly see what it looks like. Make sure you have the right pieces. Again, make sure you are in degrees in the calculator you're using. And then this gives us a value of 6.53 approximately, just rounding that to 2 decimal places. And so now I have that value of B. So once I have B, I can now go into C. Now again, do not default to Pythagorean theorem. This is not a right triangle, and you cannot do a squared plus b squared equal to c squared. You need to reset up your ratio. So again, I'm going to use that relationship of sine of 50 degrees over 10 equal to, now we're going to do the other direction, and we found lambda to be 100, so I'm going to say sine of 100 degrees over c. We're going to do the same situation. I'm going to multiply this way, so that gives me c sine of 50 degrees equal to multiply this way, 10 sine of 100 degrees, and then divide to get c by itself. So again, make sure your calculator is in degrees. Input that. If you struggle with getting these answers like I've gotten, just reach out and I'll be happy to help you to get these exact answers. And round it. This is just 2 decimal places. It's 12.86. And so now we have gotten all 3 angles. We have gotten all 3 sides. And we just used it using that simple proportion. So mathematically, the solving of this is way less difficult than some of the other things we've been doing. But you have to know how to set up your ratios, and you have to have degrees on your calculator. Let's do another situation. Here's example 2. It says, in the triangle here, solve for the unknown sides and angles. So in this one, I have 2 sides and 1 angle, so I can't just start adding them up and find that missing one. So I'm just going to work with the ratio that I know to be, and I am going to pivot off of this one here, the fact that I have sine of 85 and 12. And that's going to be the one that I kind of just pivot off of in order to find some missing stuff. And so this will be step 1 for us. And so then let's maybe go for this angle B over here. And I'm choosing angle B because really 9 is the only other set of information that I have. So I'm going to say sine of beta over 9, and then again I'm just going to cross multiply like the previous example. So I'm going to multiply this way. That gives me 9 sine of 85 degrees equal to multiply this way, 12 sine of beta. So our steps for solving are going to be a little bit different on this one. I'm going to divide by 12, and so then that gives me 9 sine of 85 degrees over 12 equal to sine of beta. And then from there, I'm going to have to isolate that angle beta, and so we're going to use our arc functions. And so if I were to arc sine both sides, that would eliminate the left-hand side. So that would just leave me with beta. And then on the left-hand side, I'm looking at, in my calculator, arc sine of 9 sine of 85 degrees over 12. And we want to figure out what value that is. So two approaches that I would do, I would either one, plug in your 9 sine of 85 degrees, make sure you're in degrees, enter. Divide it by, take that answer, divide it by 12, and then arc sine that answer. Or if you're using the on-screen calculators, you work through the homework, that'll be there on the exam. I would do, you could type all of this in because you can clearly see that everything's in the right places, but check yourself on whatever device you are using and make sure that you are able to output 48.34 degrees. And I say go ahead and check that because if you're not getting the right answers, you're just hitting the wrong buttons. I want to check it now in the notes where we know the given answer before you get frustrated on the homework that you don't understand it, when really it's just a matter of whatever device you're using. So now we have that angle beta is 48.34 degrees. And so I can then just say, you know what, for part 2, let's just go ahead and find that last angle. So I'm going to say 180 degrees minus the 85 degrees I know, minus 48.34. And if we do this one next, you might already have that number saved in your calculator. You could just do minus the answer, and you should get 46.66 degrees. And so now we have this missing angle of 46.66 degrees. So the only thing that we need to find now is our side A. And so for step 3, we're just going to set up our ratio again. So I'm going to say sine of 85. Now I'm going to go back to this known one just in case I made a mistake somewhere in my calculations on part 1 or 2. At least I know that to be sure of that's what it is. Now obviously if we miss beta and we're subtracting and we miss that last alpha angle, this one will probably be a little off too. But again, I always want to go back to my known one. I don't want to use rounded answers along the way. So that's why I'm going to use this 85 and not one of the other ones to solve it out. Now I do have to use sine of 46.66 degrees in order to figure out A, because of that relationship that these are opposite of each other. So I'm going to come down here and finish out this calculation. So in order to get this, I'm going to have to cross multiply. So I'm going to say that would be A sine of 85 degrees equal to 12 sine of 46.66 degrees, divide by sine of 85, divide by sine of 85. So A is equal to, I'm going to go into my calculator, and you should get about, when I round to 2 decimal places, 8.76. And so up here in our given triangle here, we have 46.66 degrees here, and we have in our side A to be 8.67. Now when you finish with a problem, your sides, because we're setting up these proportions, check and see if your answer makes sense for the problem. And what I mean by that is if you have, you can see that 46.66 is my smallest angle, then opposite of it should be the smallest side, and it is. And then you can see that 85 is my largest angle and 12 is my largest side. That is because of the proportions of how it's set up and how those things correlate. You can see that 48 is a little bit bigger than 46, and so its side is a little bit bigger than 8.76. So kind of do a mental check as you work through this to make sure you're on the right path. And then if that relationship doesn't work out, then you know to go back and maybe check some calculations or how you entered it. So the law of sines is very handy. It can be very useful. But you can see how with the law of sines, you have to have an angle and side that correspond to get there. But what if you don't have that? Well, that's where maybe the law of cosines is going to come in. The law of cosine says that given a triangle with angles and sides opposite labeled as shown, so same labeling, you can see alpha is across from A, beta is across from B, etc. Then the law of cosine says that a squared is equal to b squared plus c squared minus 2bc cosine of alpha. Whew, that's a lot. Now these laws, the identities guide that is earlier in the module will be what is given on the exam. And then if you go ahead and skip on to the review, you will also see the image that will be given on your test. And so I don't want you to stress about missing one of these little details of memorizing this. But let me show you this. You will see that if I am working with side A, that I'm going to have its corresponding angle over here by cosine. And then the rest of the letters are going to be the two sides. And so that relationship does exist. And so this can be assimilated for side B as well. B squared would be equal to a squared plus c squared, so the other two sides, minus 2 times, multiply those sides together, times cosine of the angle of the side we were looking for. C squared would be b squared plus a squared minus 2ab. Again, it's just the two sides that we aren't looking for. Cosine of the angle that corresponds to the side that we're trying to solve for. So that can be manipulated around to whatever side that you are missing. So when do you know to use the law of sines? Well, one, you're going to use the law of cosines. I misspoke. When do you use the law of cosines? If you have two sides and their included angle. And so that would be the situation if you have a side angle side situation. Part 2, you're going to use the law of cosines if you have 3 sides. So side, 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 and no angles. Because you can see in that situation, even the law of sines could not be used because we don't know anything about those angles in order to set up a ratio to start with. And so here's a fun problem. You're going to see this in your homework as well. It says, suppose a boat leaves the port, travels 10 miles, turns 20 degrees, and then travels another 8 miles. How far from the port is the boat? What a fun problem. I know everyone loves a good problem like this. If a picture is not given, always draw a picture. Drawing a picture is the most handy advice I can give you in this unit. And so it says a boat leaves a port and travels 10 miles. So this is where the port is here. And then it says it turns 20 degrees. So this is where we have that slight turn of 20 degrees and then travels another 8 miles. How far from the port is the boat? Well, when the boat returns, it's not going to go 8 miles and make another little slight turn and come back. It'll just go straight back. And so that's what we're looking for. We're looking for this side, and let's just call this side C. That's the side we're looking for. And so I'm going to say, you know what? If I call that C, then I'm going to say C squared is going to be equal to, you square one side plus square the other side minus 2 times, multiply the sides together, cosine of the angle opposite the side you need. So we are going to have to figure out that angle. And let me draw this a little bit bigger. This angle here is 20 degrees. And so that means from here all the way back over to here, since this is a straight line, that would be 180 degrees total. So 180 minus 20 tells me that this interior angle here that I'm needing is 160. So cosine of 160 degrees. And so I want to first input in my calculator this entire long thing. Make sure you're in degrees. And then in order to solve for C, I would have to square root that answer. And when you work through those calculations again, hopefully you're outputting these answers very well. But if you need assistance, reach out and I'll help you with whatever device you're using. And this gives us a total of 17.73. Now it says, suppose a boat leaves and travels so many miles, turns degrees, travels another miles. How far from the port is the boat? And so our correct unit for this would be 17.73 miles. And so you can see, if I were to take all the words out of this situation, we're just finding a missing side. So don't let the boat and the port and the miles throw you off. See what you have. If necessary, draw a picture without the boat in there. Just draw a triangle. See what you have, see what you're missing. Let's do another one. So this one maybe be a little less stressful. There's no boats and ports going on. But it says in the triangle shown here, solve for the unknown sides and angles. So these are similar to example 1 and 2. I'm just trying to find all the missing pieces. And so what I'm going to do first is let's kind of see what we have and assess the situation. I have 30 degrees, but I do not have the side corresponding to it. I have 2 sides, but I cannot do Pythagorean theorem because it's not a right triangle. It doesn't matter what your picture looks like. You might say, well, that kind of looks like it. If it does not have a square in the corner, you cannot clearly, factually, with confidence say that that is 90 degrees. And so step 1, I'm going to solve for x, because if I could get x, then I would have that pivot point of that ratio, and I could go back to my laws of sines that had a little bit better arithmetic. And so in step number 1, I'm going to set this up to solve for x. So I'm going to say x squared is equal to 10 squared plus 12 squared minus 2 times, multiply your sides together, cosine of the angle opposite of it. And I'm just going back to that formula every time. You can have that handy. You could even print that identities guide that is listed in the module. That would be very helpful for this process, just to kind of have that handy to be able to use what you're given. So when I work that through, again, once you get that answer, you then need to square root both sides to get our x, and you should get a value of 6.01. And so now that I have that 6.01, that would be our x, I can find all the other pieces. Since in that first step, we get our 6.01, I now have this ratio, so I can go back to the law of sines in order to help us to solve for these other angles. And so I'm going to say sine of 30 degrees over 6.01 would be equal to, let's find this one first. And so that would be sine of theta over 10, because I'm going opposite from that angle. Cross multiply, so that gives me 10 sine of 30 degrees. Multiply this way, equal to 6.01 sine of theta. And then I'm just going to divide by 6.01. And so that would give me sine of theta equal to this value. So 10 sine of 30 degrees over 6.01. I don't want to grab it yet because I might want to just input it all when I work with my on-screen calculator. So then I need to get theta by itself, and so I'm going to use my arc sine function so that those will cancel, and then I'm looking at arc sine of this value. Using your calculator, you should, again, in degrees, click through them correctly, maybe find this number first in your numerator, divide it by 6.01, then do arc sine of that answer, or gently type that into your on-screen calculator, checking your details, and you will get a value of 56.30 degrees. So up here, erase some of my markings. We have this side to be 6.01. We now have this angle to be 56.30. We got to use our law of cosines. We got to use our law of sines. And so for our last step, since we have two angles, I'm just going to say 180 minus 30 degrees minus 56.3 degrees. This should give you approximately 93.7 degrees. Whew. And so that's a pretty neat problem that you can use law of sines, law of cosines, and then you can find that missing angle. Again, see what you have, see where you can start, and then go from there. So let's do another example. And on this one, I have no angles. I just have three sides. And so you absolutely want to first go to law of cosines in order to get some kind of information. And so what I'm going to do, number one, just kind of step us through, is I'm going to find this angle right here. If I'm looking for this angle right here, 20 is what's going to be by itself. So I'm going to say 20 squared is equal to, I'm going to do each side squared, add it together, minus 2 times each side multiplied, cosine of, and let's just call this angle theta. Now we're going to have to work through a little bit different steps. We're actually going to have to not just type it all in like we did on the previous ones. So 200 squared would be 400. I'm going to have to work through it because there's my theta and I got to get it by itself. Equal to 13 squared, which is 169, plus 11 squared, which is 121, minus, multiply these three numbers together, 286 cosine of theta. Now if I combine these two pieces together, that gives me, let's see, 290 minus 286 cosine of theta. Try and get theta by itself, so I'm going to subtract 290 from both sides. That gives me a value of 110 equal to negative 286 cosine of theta. I'm going to divide by negative 286. So I have cosine of theta equal to this fraction. And then just like we did in the previous ones, I'm going to arc cosine both sides to get rid of that cosine. Make sure your calculator is still in degrees. And you should get a value of 112.62 degrees. And that makes sense for this problem because it's opposite of our hypotenuse, so it should be our largest angle. So getting such a big number is okay. Now that I have that ratio, I'm going to go back to my law of sines. And I'm going to say sine of 112.62 degrees divided by 20 is equal to sine of, let's find this angle up here, let's call it beta. Sine of beta over 11, because I'm just using the side that's opposite of it. Cross multiply, that gives me 20 sine beta equal to 11 sine of 112.62. And divide by 20. And arc sine both sides, so that gives me beta equal to arc sine of 11 sine of 112.62 degrees divided by 20. Approximately, once you plug and chug through that calculation, 30.51. And then lastly, we can find our missing angle. So we can say 180 minus 30.51 minus 112.62. And you should get approximately 36.87. And again, do a little mental check. 36.87 would be down here. We figured out beta to be 30.51. 11 is the smallest size. 30.51 is the smallest angle. And so that looks like it's all lining up for us. Just kind of a quick mental check. But again, law of cosines, law of sines, and then subtracting out those angles. Let's step it up for these last two examples and do some more. I know you just love that boat and port problem. Let's go kind of into that realm because you are going to see some of these harder problems on your homework and the quiz that follows. To measure the height of a hill, a woman measures the angle of elevation to the top of the hill to be 24 degrees. This is your angle of elevation. Then she moves back 200 feet and measures the angle of elevation to be 22 degrees. So this angle is 22 degrees, and this length here is 200. Find the height of the hill. And so when we're working with this problem, we have two different triangles going on. Our goal is to find H, but we might have to find some stuff in between. So first thing I want to figure out is maybe some of these missing angles. Well, if I consider this triangle here, I have my angle of 22, I have my angle of 90, so I know that this entire angle would be 180 minus 90 minus 22, and that gives me an entire angle of 68 degrees. Now, if I do the same thing for my smaller triangle, let me erase some stuff. This triangle right here, and I again say, okay, well, that would be 180 degrees minus that 90 degree angle minus 24 degrees. I get an angle of 66, which would be this angle. So I know of these triangles, I found some missing information, that this angle is 66 degrees and that this angle is 2 degrees. And the reason I would want to do that is because I have this side right here that's just this piece, and now I have its corresponding angle. So I can find this side right here now. Let me draw that down. I think I lost some of you. Here is this triangle right here, move down. So this is 22 degrees, this is 2 degrees, and this side is 200. So I am going to use this ratio in order to find, with this angle, this opposite side. If I can find that opposite side, lots of erasing on this diagram here. If I can find this side here, and let's call it X, I have more information to get me over here to this side with H, but I'm having to pivot off of just knowing that this small little piece here is 200. So that's why I'm working on that triangle. So first I'm going to say sine of 2 degrees, remember this is opposite of my angle, over 200 is equal to sine of 22 degrees over, let's call it X. So that gives me X sine of 2 degrees equal to 200 sine of 22, divide by sine of 2, divide by sine of 2. So X is equal to, that calculation gives me 2146.77 feet, which, I mean, this little piece was 200 foot. So I'm not shocked that I'm getting a 4-digit side here. So if that is, let me erase some. If this side here is 2146.77, and I now just consider this triangle, which is a right triangle, which throws me back into some previous sections that I know, and I want to solve for, let's call this, well, it's already labeled H, we'll call it H. Think about what you have. I have an angle, I have its opposite and its hypotenuse. And so if you consider SOHCAHTOA are ratios of sine, cosine, and tangent, opposite over hypotenuse is sine. So I'm going to go back to that configuration. Compared to the other 5 examples, I'm able to go back into this because we are now dealing with a right triangle. And so I'm going to say, step 2, sine of 24 degrees is equal to opposite, which is H, over our hypotenuse, 2146.77. I'm going to solve for H, so I'm going to multiply both sides by 2146.77, so that gives me H is equal to 2146.77 sine of 24 degrees. Make sure your calculator's in degrees, which gives me 873.17. So I really love a problem like this because in this problem you were putting together lots of knowledge that you were going on. But again, let me emphasize, we were only able to go in this part here because you have a right triangle when I pull that triangle out. So try to use the information you have. That's what made me cue to start with using something with that 200. Pull apart separate triangles as you need it to kind of see clearly what information that you have. And then think about what you know. You can't forget some of these basics we did along the way. I know, a little confusing. Try and process through that. Maybe try it again on your own, especially because it'll show up in your homework and your quizzes. But reach out if you need additional instruction or to set up a time to meet and kind of discuss it one-on-one. So let's look at this next one, example 7. So I'm going to erase a little bit from example above us. A pilot is flying over a straight highway. He determines the angle of depression to 2 mileposts, 4.3 kilometers apart, to be 32 degrees and 56 degrees. And you can see a diagram has been given. Find the distance of the plane from point A and the elevation of the plane. And so let's fill in some information we did not mark. The distance between them was 4.3 kilometers. And he would like to know the distance of the plane from point A. So this piece right here, let's call that X. That's my end game. That's what I need to figure out. So let's figure out what information we do not have on here. Well, if this entire piece here is 56, 56 minus this little angle 32 gives me an angle of 24 degrees. If I know that that angle is 24 degrees, and I know that he's flying it says he's flying over a straight highway, that means that his flight path and the highway are both parallel. And going back to your days of geometry, when you have a line that cuts through two parallel lines, then the angles that it creates are going to be similar angles. So that one would be 56 as well. And so if it's straight again, 56, if we loop this angle all the way around, it'd give me a total of 180. 180 minus that 56 would give me 124 right here. If I consider this triangle here, and I see that I have two angles, I could add that 124 and 24, subtract it from 180, and that would give me the angle down here by B to be 32 degrees. And so I'm just using my geometry skills, what I know about 180 degrees, what I know about triangles, and putting this all together. And why would I want to find all these angles? Well, now, since I have 43, and I have the angle opposite of it, and I have all my degrees, I can take this angle, and the side I'm looking for, X, opposite of it, I can just use my law of sines. And so I'm going to say sine of 24 degrees over 4.3 would be equal to, and I'm trying to find X over here, so I'm going to use sine of 32 degrees over X. So it gives me X sine of 24 equal to 4.3 sine of 32. And then I'm going to divide by sine of 24. So that gives me X equal to, make sure that you are in degrees in your calculation, 5.6 kilometers. So as you saw us go through this process in this example, figure out, what do I know? Figure out some things you can pull out of it. I found all three of these degrees, and then I saw that I could use that law of sines to get me there. So I hope this helps as you kind of work through these. Don't be scared by these problems. Start, take some small steps, try a formula, work through your calculations, figure out if you can find something else missing. And then, but if you're getting frustrated, you're getting stuck, please reach out to me. I'll be happy to help you along the way.